Hello everybody. Today I want to talk about solving literal equations, looking at some harder examples. So remember, a literal equation is an equation that represents a situation or something from everyday life. And when we say everyday life, we could be talking about any area of like study, such as biology or chemistry or shapes like volume, whatever it may be. It represents something from everyday life. Okay? Now, some of the practice problems those equations won't represent, but oftentimes they do actually represent something from everyday life. So with literal equations, there's a couple key things to remember. The first thing that we recommended in the last video lesson was to circle the variable you're solving for. Okay, because at the end of the problem, you want that variable equals something. So we also want to look, when we circle, what operation is happening to that variable. So right now, the variable we're trying to solve for is actually doing an operation. So what happens for this particular problem, since we're solving for x, is we would actually multiply both sides by x. Now, typically, 95% of the time, if I had to qualify it, or quantitate it, I should say, we don't move the variable we're solving for. But you cannot solve for a variable that's in the denominator of a fraction. So by multiplying both sides by x, we actually move it to the numerator of the other side. So now we have xs equals p. And now the equation is easy to solve. We're solving for x, so we divide both sides by s. So these cancel. Our final answer is x equals p over s. Remember, with literal equations, you typically won't get just a numerical answer. You'll get an answer that has a lot of variables and numbers integrated into the final answer. So let's look at another example. So here we have 3 times the quantity, t minus 7, that's a t, equals g. And we're solving for t. There's actually 2 major ways you can solve this one. I'm going to go with the way that most of you would probably feel comfortable with, and that would be distributing. So anytime you have parentheses, good idea to distribute to eliminate your parentheses. So we get 3t minus 21 equals g. Now remember, we're solving for t, so we have to isolate the term that has our variable in it. So we're going to isolate this 3t. So in order to do that, we're going to add 21 to both sides. Since there's a g on the other side, we can't do any real math on that or any computation. So 3t, equals g plus 21. And now we can solve for t completely by dividing both sides by 3. Now, when we rewrite that problem, I'm going to write the answer over here. We could write that as g plus 21 divided by 3. That's acceptable. We could also take it a step further. Let me just write this answer on the other page. We could also take it a step further and divide each term by 3. So if we divide each term by 3, well, g divided by 3 is just g divided by 3. Can't really do a lot with that. But we can divide 21 by 3 and get 7. So some people like to do that is if you can simplify, one of the terms in the numerator, then they like to do that. But either this answer or this answer are both acceptable answers. I wanted to show you both ways though, so that way in case you see a different answer, you know how it was gotten, or how it was obtained, I should say. So most of the time, if you have parentheses, distribute. Again, there's another way to solve that. If you want to know that alternative way to solve this equation, please send me an email or ask me in class. I'd be happy to show you some different problem-solving strategies. All right, so what about this one? We have 3m minus x equals negative 4m. So we're solving for m. But wait a second, there's 2 m's in our problem. Well, think about if you had 2 x's in your problem in a quote-unquote regular linear equation. You would get those variables on the same side. So that's what we want to do for this problem. Now, there is one way of doing it that's a little bit more efficient than the other way. If we get this 3m over here by doing the inverse operation, now the m's are on one side. So we're solving for m. So I'm going to circle those. Again, that's the variable solving for. But since there's m on opposite sides, we've got to get them on the same side. So I'm going to subtract 3m from both sides. And again, this way of doing it is the most effective way because now we have that variable on the other side. So you have negative x, and we combine like terms here. These are like, which we're lucky because a lot of times with literal equations, you won't always have things you can do computations with. We get negative 7m. And now we have that variable into one single variable. Now we can completely solve for m by dividing both sides by negative 7. So we get m equals, and the only thing we could do with that, we don't know what x is, but a negative divided by negative is positive. So our final answer is x divided by 7 equals m. So if you're solving a literal equation, you have an equation with variables on opposite sides, you want to get them on the same side. Okay, so how about this one? So let's say we're solving for c. Now take a look at that. See if you could figure out what that actually represents. This is a literal equation that represents something in real life. See if you can figure that out. There's an F and a C. Well, this is the formula for converting Celsius to Fahrenheit. As a country, for our everyday purposes, we use more Fahrenheit. Celsius is used a lot more in, scientific things because they use maybe some extremely high or extremely low temperatures. But we typically use Fahrenheit for our temperature in the United States. So we're solving for C. So here's the term that contains C in it. So the first thing we want to do is get rid of this plus 32 by subtracting 32 to both sides. So we get F minus 32. Remember, if you're subtracting, just write what you have vertically from left to right because the order is important. Equals 9/5 C. So now we could actually divide both sides by 9/5 because that's being multiplied by C. But people get a little bit confused there with the simplifying. So watch this. One of the things we talked about at the beginning of the year was if you have a fraction times a variable, one of the ways you can eliminate that is multiplying by the reciprocal. Because watch. Here we're multiplying by 5 and dividing by 5, so they cancel. Here we're multiplying by 9 and dividing by 9, so they cancel. So that's why it works. So whatever we do to one side, we got to do to the other, right? But because there's two terms there, we got to put in parentheses. Okay? When you do the operation of multiplication and division on both sides, you have to make sure you do it to everything on the other side. So there's your final answer. So 5/9 times F minus 32 equals C, or Celsius. So why was that useful? Because if I want to go from Fahrenheit to Celsius, this is an easier formula to use. If I want to go from Celsius to Fahrenheit, this is an easier formula to use because now I just plug it into my math. I don't have to solve an equation every time. That's why this stuff is beneficial. Okay? Okay, so for our last one, we have an area formula. And just so you're aware, it's the area of a trapezoid. Okay? And here we go. Its area equals the height and then base 1, the height times, the quantity, base 1 plus base 2. And that's all divided by 2. So what happens here is we have subscripts. Okay? So basically, since there's two bases, we need a different way of representing each base, so we use those subscripts, the b sub 1 and b sub 2. So that they're, in essence, like one variable respectively, okay? So in this case, we're solving for b2. So a couple different ways you can handle this. Well, if your whole problem's a fraction, what I recommend, and let me get rid of one of the circles there because I always want you to circle the variable you're solving for. But since this whole problem is a fraction, the way it's written, I do recommend you get rid of that fraction first. So let's multiply both sides by 2. Bam. Well, now look. 2a equals hb1 plus b2. So I don't know about you guys, but that looks a lot nicer. So if your whole one side of a literal equation is a fraction, probably a good idea to multiply both sides by the denominator, and that will eliminate that fraction. So if you wanted to here, you could distribute. There's another way to do it, but most people are comfortable with distributing, even though we're solving for b2 because it's inside parentheses. So if you distribute here, we have 2a equals hb1. Now remember, that's like two variables there, plus hb2. We're still solving for b2, but this is the term that has our variable in it. So we got to isolate that first. So hb1 is being added to that term, so we subtract hb1 from both sides. Since I'm running out of space, we're going to rewrite the problem. So 2a minus HB1 equals HB2. And we're still solving for B sub 2, excuse me. So our last step would be divide everything by H. Now I know there's a lot going on here, but just take your time. So we do have the answer. We could write it as 2a minus h b sub 1 divided by h equals b sub 2. So that is an acceptable final answer. Now because one of these terms in the numerator has an h in it, if you wanted to, you could take it a step further and divide each of them by h. Okay? So if I divide this by h, doesn't really do much, so we get 2a over h. But if we divide this term by h, the h's will cancel, right? You see that? So I'm not going to rewrite that, but that will cancel. So since the h's cancel, you just get minus b1, and that equals b2, which is another way you can express this answer. So both these answers would be acceptable. All right, so there's literal equations. The key things are circling the variable you're solving for, isolating the term that has your variable, and doing the inverse operations, okay? And if you have parentheses, for most of you, it's probably a good idea to distribute. If you have variables on opposite sides that you're solving for, just like solving a quote-unquote regular linear equation, get them on the same side. Fractions, most times you want to eliminate those first by multiplying both sides by the denominator. But use the skills. Think about the skills you learned previously, even though this looks totally new at times, and it looks a little confusing because of all the variables. You're just, when you're solving a literal equation, you're getting that variable by itself. So for this particular problem, we were getting b sub 2 by itself. So thank you very much for your attention. Hopefully you found this video lesson helpful. If you have any questions at all, please let me know. Have a fantastic day, everybody.